Okay, today we have a few things to do. So exponential function review, we need to look at that and see what questions you have. And then you need to turn in your category 2 EOC review. I'm going to pass out the category 3 review, which will be due next Monday, so you get a full week with it. And then we're going to do slide 22 and then domain and range for exponential functions. This will finish out the exponential functions unit, and then we will move on to quadratic functions, which is the last type of function in Algebra 1. So let's first look at this review here. What questions do y'all have? Raise your hand if you want me to go over any of them.
23.
Okay, let's look at 23. Create a model or equation for each scenario. Use function notation to answer each question. So let's see. How do we do exponential functions? It's like f of x equals what? A, b to the x. What does a represent? No. Slope goes with the exponent.
Oh, yeah. What's the start?
Yeah, so this is just our start or our initial value. And what is the b?
Now.
The rate. Like what it's being multiplied by every single time you move up. So for this one, what is our start value? 2,400. So times, it doubles every 13 years. So what would be our rate? 2, but it says every 13 years. So instead of it being to the t power, we need it every 13 years. So in 1 year, it's only going to do 1/13 of that, right? 2 years will be 2/13 of that. So our exponent is actually 1/13t. So this is the first time we have talked about that. Our rate would be 1/13 because every 13 years it doubles. So we have to do 1 out of 13. So then if we know how to do this, then we can do this one, right? A new disease is killing the local frog population. The half-life of the population P is 2 weeks. If there are currently 6,000 frogs in the swamp, how many will there be in 11 weeks? So it says every 2 weeks, right? Every 2 weeks, what is going to happen? What's going to happen to the population? It says half-life. Because the disease is killing. So what's happening to our population? It's decreasing. So f of x equals, what's our initial, our start amount? 6,000. And then what's our rate? It's a half, so we can write it as 0.5, right? And then every how many weeks? 2 weeks. So how would we write our exponent? If this was every 13 weeks, we write it as 1/13. 1/2 W. Let me get it. So then we want to know for 11 weeks. So we can either put it in our table of values, our y equals, and look at the table, or we can plug in 11 right here. I'm just going to put it into y equals. So everybody do this with me. Get your calculator out or use the calculator on your computer. Make sure that your exponent is 1/2 the variable. Go ahead and put that in. Are we going to be able to see this on our original graph? Our original graph goes -10 to +10, X and Y axis. So we're not going to be able to see it on our graph unless we change our window. So let's just look at our table, and we're looking at 11, week 11. So if you get an amount that goes up, increases, because this says it's killing the population. If you get something that's larger than the initial, that means you did it wrong. But since we got something that is smaller, 132.5, it says round to the nearest frog. So what would that be? 133, right. If there are currently 6,000 frogs in the swamp, how many will there be in 11 weeks? Or you can write 133 frogs. Okay, raise your hand if you have another question that you would like me to go over. 25. Construction company purchased some equipment costing $300,000. The value of the equipment depreciates at a rate of 14% per year. What will be the value of the equipment after 9 years? So let's write our function. F of x equals, what do we put first? 300,000. And then what is our rate? It depreciates by 14%. If it depreciates, remember what we talked about last week when we talked about the percent graphs? Do you remember that? I'll pull it up. Yep, because anytime it depreciates, it's going down by 30%. Then we take 100%, we subtract the percent that is depreciating by, and we get the rate. If the rate is less than 1, then that means it's going down, which this is going down. So we would take 100% and take the 14% away from it. If it appreciates, we add the 14% to it. But depreciate means we're going down. So that would be 86%. So it'd be 0.86 as our rate. And then it says per year, so we don't have to do any of this stuff because it tells us per 1 year, so that'd be to the T. It says, what is the value after 9 years? So you can use your table of values, or you can just plug in 9 for T. The only number that is being raised to that T value, or to the 9 in this case, will be the 0.86. So y'all go ahead and solve that one if you haven't already. So if it depreciates, what should the value be? Less than the start, exactly. And how would we round this? What are we dealing with? Money. So what would we round it to? The hundredths place. Yep. Good job. All right. What other questions do y'all have before you turn it in? 26. Okay. Newly reported case of HIV in thousands from 2010, 2010. We already have our function. Oh, maybe I took 26 off for the online. That's weird. Did y'all do 26? Okay, let's not worry about 26 because I think I actually took it off on the online one and then printed it for y'all. So we won't worry about it. I don't know what happened.
Well, guys. Putting on your tea. Oh.
Okay, we are moving on. You should already have turned in your exponential functions review and then reporting category 2 EOC review. I'll be passing out reporting category 3 EOC review here in a little bit. Let's look at our digital interactive notebook. We need to look at slide 22.
Wait, how do you put the new slides in the
So on slide 22, let me zoom in on this. Quiet down, please. Shh. We have the formula here, which we talked about with that review. A, B to the X. A is your starting amount. B is your growth factor. And X is your multiplier or common ratio. We have the exponential growth function. Do you see this? A and then 1 plus R to the X. So that's where I was saying on that percent increase and decrease. Whenever it's an increase, you add 100% to it. And then whenever it's a decrease, you actually subtract your percent from it. So R is a growth rate as a decimal and not as a percent. So if we look at this function, it says complete the table for this function. 3 raised to the X value. So we can put this into Y equals. I'm going to maybe do this. There we go. So Y equals 3 raised to the X value. And then look at our table of values. What do you notice about the Y values? They're decimal. Do they ever equal a negative? No. But what do they do? Do you know what these numbers represent?
You told us that.
Scientific notation, right? So it's getting closer and closer to 0, but it never actually touches. Do you know what that's called whenever you get close and close and close to a number, but you never actually touch it? It's called your asymptote. Weird word, right?
Yeah, I remember that.
You remember that? So we learn, well, we have it in our vocab. A line that is approached and may or may not be crossed. So that is an asymptote. So here, your asymptote will be where Y equals 0. So let's put a line there. Let me insert a line. And I'm going to color this line, make it a little, I'm going to, yeah, and color it like a green. We are on our digital notebook, slide 22. So this is called your asymptote. It's at Y equals 0. It's the line that never gets crossed. So let's fill in the table. Let's go to when X equals -2. The Y is 0.111. Well, 1 repeating. It gets really close to 0. Okay. Now let's do -1 from our table. 0.33. repeating. What will our 0 value be? That's our start.
Y-intercept.
Yeah. What will it be? Where is it going to cross the y-axis? Let's see. It's at 1. Okay, and then after 1 year, it'll be 3. And then 2. What's the rate? What are we multiplying by? From 1 to the next?
3.
Times 3. So what will 2 be with 9? Yeah. So let's plot some points. So I need to make some shapes. I thought these were mobile, but they're not. So I'm going to make some points. Red. Okay, so 0, 1, 1, 3, 2, 4, 5, 6, 7, 8, 9. And then 0.3, and then 0.1. Then do your scribble tool to draw it. Make this a little darker. And then you know this is going to follow along that line, but never actually touch. So I need to actually move it up a tiny bit. There we go. Identify the y-intercept. So we have completed the table, graph the function, identify the y-intercept. So where does it cross the y-axis? At 1. So it'd be 0, 1. Identify the common ratio. What are the numbers moving by? 3. 3 is our common ratio. What is the shape of the graph? Do what? It's exponential. And it's also increasing. What about exponential growth? That's what we'll write. If it was going down, it'd be an exponential decay. Identify the domain and range of the function. Explain what they mean. Do y'all remember what domain represents? The x values. So if we look at from negative 10 to positive 10, what do you notice about the x values? Is anything off limits? Going from left to right, is it going to go as far left as it can? So what would that be? What's a number or a symbol that represents negative infinity, right? And then what about the x values? Positive infinity. So that's what we're going to put. Negative infinity. I need to do the symbol. So insert special characters, then draw your infinity symbol. I'm going to click it twice so it's in there twice. Negative infinity is less than x is less than positive infinity. So this means all real numbers. And then the range is the y's. How are the y values going to be represented? 0 to infinity. So how can we represent that without saying 0 to infinity? What are the y values going to be? Greater than infinity? Or greater than or equal to infinity? No, hold on. 0. Sorry, 0. Greater than 0 or greater than or equal to 0? Greater than. We cannot say it's equal to 0 because the asymptote tells us it'll never touch y equals 0. It'll never go below that. So our range is going to be y is greater than 0. What that means is y values are from 0 to infinity. So we can write it as that or like this. I'm going to insert that over here. So those are two ways of writing it. You could see it both ways. Okay, let's look at the other page. Identify the initial value, the growth factor, and the growth rate of the given function. Initial value. What is the initial value in this function? What is our growth factor? 1.04. And what is our growth rate? It would be what is being increased or decreased by. So you're at 100%. So if it's at 104%, then what is the rate? 104%. 4%. So it's a 4% growth. You would find out how much more than that 100%. For 2 and 3, find the new total or value. Show all steps. The height of a mountain shrinks 0.5% each year. If the mountain is 15,560 feet tall, how tall will it be after 20 years? So let's write our function. F of x equals, what do we put first? The start, so 15,560. And then we need to do, before this, I'm going to take the 100%, right? And you subtract 0.5% from it to find our growth rate. So it's a decrease, it's a decay, it's going down, the mountain is shrinking. So what is 100% minus 0.5%? What? 99.5. So that is our rate, but then we write it as a decimal. So it'll be 0.995 raised to the x value. So how can we find out how tall it'll be after 20 years? Put it into y equals. Find out what f of 20 is. So go ahead and do that. Okay. And we need to round it to the nearest feet, right? So you can put it into y equals, look at the table, or you can plug it in. Like that, either way. So f of 20 equals 14,076 feet. Yeah. Last problem. The population of a small town grows 6% each year. If the population was 3,525 years ago, what is the population now? So we need a function. It grows 6% every year. So what am I going to do to 100%? Am I going to add or subtract it? Add. That is my rate, 1.06. And then my function is going to be what it starts with. If the population was 3,500, and then what is the population now? So it's going to grow by 1.06 raised to the x. And we need to find the population now, so we do f of 25. What did y'all get? Did y'all get the same? Oh, no, I don't need to do that to the x. I need to do it to the what value? 25? 15,022? Is that right? Is that what y'all got? That first one I did to the x value, and it gives us a value for x. So we need to round to the nearest person. So 22. Okay, so your assignment is going to be to do the domain and range for the paper that I passed out, which is actually these other slides. And then we will go over it on Wednesday for each one of these, okay? Make sure you insert those slides.